You've heard it a million times, right? Data is the new oil, the new gold. But let's be real. On its own, data is just a giant, chaotic mess. It powers literally everything we do online, but it needs to be tamed. Today, we're going to pull back the curtain on the incredible machine that does just that.
I mean, seriously, stop and think about it for a second. Billions of transactions, millions of people, all hitting the same system at the same time. How does your bank know your deposit went through safely while 1,000 other people are making withdrawals? How does that online store keep its inventory perfectly in sync? It feels like some kind of magic, but it's not.
The answer is something way more engineered and, honestly, way more impressive. It's called a database management system, or for short, a DBMS. This is the true unsung hero of our digital world, the engine that's running silently behind almost every single app you use every day.
So, what's this machine actually made of? To really get how it works, we've got to look at the fundamental parts. Come on, let's break down the anatomy of a DBMS.
First up, you've got the software. And really, you should think of this as the brain of the whole operation. It's a super complex set of programs that acts like a conductor for an orchestra, coordinating every single request, making sure all the data gets stored and retrieved exactly right. Without this software, everything else is just a pile of useless parts. Of course, that brain needs a body to live in, and that's the hardware. This is all the physical muscle. We're talking powerful servers that do the heavy lifting and huge storage drives that hold all that precious data, sometimes terabytes or even petabytes of it. This is the physical foundation that makes the software's commands a reality. And what's this whole machine designed to protect? Well, the data itself. This is the whole reason a DBMS even exists. It's the valuable raw material being processed and managed. And this isn't just the obvious stuff like your name or your account balance. It also includes something called metadata, which is basically data about your data, super important stuff that describes its structure and rules.
And finally, you've got the users. These are the machine's skilled operators. Now, we're not just talking about everyday people using an app. We're talking about the technical experts behind the curtain, the database administrators, or DBAs, who are like the systems mechanics, and the application programmers, who build the bridges that connect the database to the apps we all use.
All right, so we've seen all the parts laid out on the table. Now, for the fun part, let's head down into the engine room. This is where the real magic happens, where we'll see how this machine processes millions of requests all at the same time without breaking a sweat. The engine itself is basically broken down into 3 critical subsystems. You can think of them as specialized departments in our information factory. You've got the storage manager, the query processor, and the transaction manager. Each one has a very specific and very vital job to do. Let's start with the storage manager. Just imagine this as the ultimate warehouse manager. Its job is to handle the physical storage of every piece of data. It knows exactly where everything is, how to grab it super fast using things called indexes, and how to put new data away efficiently. It's the essential link between the data an app asks for and the actual ones and zeros sitting on a physical disk. Next, we have the query processor. So if the storage manager knows where everything is, the query processor is the genius that figures out the best way to get it. It takes a request from a user and translates it into the most efficient step-by-step plan to get the data. And here's the really clever part. It doesn't just find any plan. It finds the absolute fastest, lowest cost plan. This is called query optimization, and it's the reason a search can take milliseconds instead of minutes. And finally, the transaction manager. This is the quality control department, and you could argue its job is the most important of all. It's the guarantor, the protector. It makes sure the data is always correct and consistent. When you transfer money from one account to another, it's the transaction manager that ensures the money is taken from one and put into the other. It's an all-or-nothing deal. This is called atomicity, and it's what makes databases so incredibly reliable. Okay, so we've got this incredible, powerful machine, but how do the operators, the programmers, and the admins actually tell it what to do? How do they give it orders? Well, they use a special set of languages that act like the machine's control panel. This control panel basically has 3 main languages, each with a very different job. First, you have DDL, the data definition language. That's what you use to build the actual structure of the database, like an architect's blueprint. Then there's DML, the data manipulation language. These are the day-to-day commands for putting data in, changing it, or getting it out. And finally, you have DCL, the data control language, which is basically the security guard, controlling who gets to see what and who gets to do what.
A DBMS sounds pretty amazing, doesn't it? But, and this is a big but, with all that power comes some pretty serious trade-offs. It's not a silver bullet for every problem. So let's step back and do a little owner's review. Is this machine always the right tool for the job? So here's the deal. It's all about balance. On one hand, the advantages are huge. You get perfectly organized data, guaranteed integrity, solid security, and built-in recovery. I mean, that's exactly why your bank uses one. But on the other hand, they can be really expensive, incredibly complex to set up, and all that safety adds a performance overhead that just isn't necessary for every single project out there. So after digging into the anatomy, peeking into the engine, and weighing the pros and cons, what's the big picture here? What's the main thing you should really remember about these complex information machines?
You know, this quote really nails it. A DBMS is a specialized, high-performance, heavy-duty tool. It's absolutely essential for any situation that demands rock-solid reliability and security. But that power comes at a cost. For simpler jobs or for things that need massive, fast scale without those strict guarantees, other tools might be a much better fit. You know, you wouldn't use a sledgehammer to hang a picture frame. It's all about using the right tool for the job. The DBMS has been a cornerstone of computing for decades now, a true titan of technology. But as the ocean of data that we generate every day just keeps getting deeper and wider, it really leaves us with a fascinating question to chew on. What's next? What will the next generation of these absolutely essential information machines look like to handle the challenges of tomorrow?